All right, so listen to this. Today we're diving into something pretty technical. Atomic operations.
Uh-huh.
Basically, how to make sure that in a distributed system, a bunch of different actions all happen together as one unit.
Okay.
Like picture buying something online.
Yeah.
You want the order to be saved,
Yeah.
the shipping to be triggered at the same time.
Right.
What if one of those fails?
Yeah. It's
What's going on?
a classic distributed systems problem. And, people used to wrestle with these super complex solutions like two-phase commits.
Yeah.
But what's fascinating here is that we're looking at the simpler, more elegant approach using DynamoDB Streams.
Okay.
And it's really about working smarter, not harder.
Love it.
Yeah.
So before we get into DynamoDB Streams,
Yeah.
you mentioned this transactional outbox pattern.
Right.
Lay it on me.
Okay. So think of it like this. The transactional outbox pattern ensures that both the data, like your order details,
Yeah.
and the trigger to kick off another action, like shipping, are stored together. It's a package deal. Either both happen or neither,
Gotcha.
and that helps ensure everything stays in sync.
Interesting. So instead of relying on separate systems,
Right.
we're basically bundling everything together.
Precisely. That's where DynamoDB Streams comes in.
Okay.
And it's like a live feed of all the changes happening in your database.
Okay.
Imagine you add a new order item to your DynamoDB table. The stream immediately captures that change.
So every time something changes in the database, DynamoDB Streams is like, hey, something happened here.
You got it.
Okay.
And the best part is that we can use this stream to trigger actions based on these changes.
Okay, now things are getting interesting.
Yeah.
So how do we actually use this stream? What do we do?
So we use Lambda functions,
All right.
and they basically become the delivery person for these events. They are triggered by the DynamoDB stream. They take the event data, like, hey, a new order was created, and they deliver that to the system that needs to take action.
So it's like a chain reaction. The database changes.
Right.
The stream notices it, and then Lambda functions spring into action to deliver the message.
Yeah.
Pretty slick.
Exactly. But there's a catch.
Uh-oh.
What happens if that Lambda function fails for some reason?
That's a really good point. We wouldn't want the whole system to, just stop working, would we?
Right.
What are our options there?
So there are a few options.
Right.
One is to keep the Lambda function's batch size small.
Okay.
So if it fails, it only affects a small chunk of data.
Makes sense.
Another option is to use FIFO queues with SQS.
Okay.
And these queues have built-in deduplication,
Okay.
meaning they'll ignore any duplicate messages.
So if the Lambda function tries to deliver the same message twice, SQS is like, nope, we got that one.
Right.
I like it.
And there's a third approach.
Okay.
And that's to handle duplicates on the receiving end.
Gotcha.
So that means making the system that's receiving the event smart enough to recognize and just ignore any duplicates that come through.
Gotcha.
It's a bit more complex, but super robust.
So it sounds like we've got choices
Right.
depending on how much risk we're willing to take
Exactly.
and how complex we want to get. But let's step back to the bigger picture here.
Okay.
Why is this whole DynamoDB Streams approach so valuable? It seems pretty powerful.
Well, imagine you're building a large-scale application
Okay.
with tons of moving parts.
Right.
DynamoDB streams and Lambda functions, they really help you manage all those moving parts much more efficiently.
Right.
They handle all that complex synchronization, freeing you up to, really focus on the core logic of your application.
So it's like having a super efficient traffic control system
Yeah.
that keeps everything flowing smoothly, even during rush hour.
Exactly.
I love that analogy.
And remember, this isn't a one-size-fits-all solution.
Of course, yeah.
But it's a very powerful tool in your toolkit, especially for event-driven architectures.
Okay.
Yeah, it's like having a team of expert air traffic controllers managing all the incoming and outgoing flights.
Right.
And making sure things run smoothly even during those peak traffic times.
That's a great way to put it. Speaking of managing traffic, one thing that stood out to me in the article was this concern about DynamoDB potentially retrying a whole batch of changes if the Lambda function hiccups.
Right.
Could that lead to some serious duplication issues?
Yeah, that's a sharp observation.
Yes, DynamoDB's retry behavior could definitely lead to some duplicate messages,
Okay.
especially if the receiving system isn't really equipped to handle them. It's like, accidentally hitting that reply all button multiple times.
Yeah.
You just end up with a flood of unnecessary emails.
Been there. So how do we prevent our system from basically drowning in a sea of duplicate messages.
Well, we need to make sure that the receiving end is, smart enough to recognize and discard any duplicates that come through.
It's like having, a good spam filter
Right.
that automatically weeds out those unwanted emails.
Makes sense. So it's not just about setting up the system,
Right.
but it's also about thinking about those potential pitfalls
Yeah.
and putting some safeguards in place.
Yeah.
It's all about building a system that can handle the unexpected.
Absolutely. A robust system is like a well-built house.
Okay.
It can withstand the occasional storm without falling apart. And that brings us to another crucial aspect.
Yeah.
Idempotency.
Idempotency.
Yeah.
Okay. I've heard that term thrown around, but
Yeah.
I'm not entirely sure I understand it in this context.
So in simple terms, idempotency basically means that an operation can be executed multiple times without changing the final outcome.
Okay.
Imagine flipping a light switch.
Yeah.
Pressing it twice doesn't make the light any brighter.
Okay. I'm starting to see the connection.
Right.
So in our system, if the same event gets processed multiple times,
Yeah,
we want to make sure it doesn't mess things up.
precisely.
Yeah.
Let's go back to our e-commerce example.
Okay.
If that order-created event is accidentally processed twice, we don't want to end up shipping the same order twice.
Right. That would be a disaster,
Right?
both for the customer and the company's bottom line.
Exactly.
So how do we ensure idempotency in this kind of setup?
So one way is to assign each event a unique identifier. This allows the receiving system to recognize, whether an event has already been processed,
Okay.
even if it's received again.
It's like giving each event a unique tracking number.
Exactly.
No two events are exactly alike.
Another approach is to design the receiving system's logic to be inherently idempotent.
Okay.
This means that even if the same event is processed multiple times, the outcome will remain consistent.
So it's about building in safeguards at both the event level and the processing level.
Yeah.
Kind of a belt and suspenders approach
Yeah, a great analogy.
to make sure things stay on track.
And this really highlights the importance of, careful design and planning.
Right.
Building a reliable distributed system, it's like constructing a complex machine. You need to think about all those moving parts and how they interact.
And that includes considering not just the happy path, but also all the potential hiccups
Yeah.
and failures that might occur along the way.
Exactly. It's about anticipating problems before they arise
Right.
and putting measures in place to handle them gracefully.
Okay.
This might involve implementing retries, fallbacks, or even manual intervention in some cases.
It sounds like building a truly robust distributed system requires like a deep understanding of the technologies and a healthy dose of foresight.
Absolutely. And it's an iterative process.
Okay.
You learn from your mistakes,
Yeah.
refine your designs,
Right.
and continuously improve the system's resilience.
So it's about constantly learning and adapting.
Yeah.
Just like in any other engineering discipline.
Precisely. And that's what makes it so fascinating.
Hmm.
There's always something new to learn,
Yeah.
a new challenge to solve.
Right.
It's like exploring uncharted territory.
I like that, exploring uncharted territory. And speaking of exploring, one thing that struck me about this approach is that it's not limited to just DynamoDB.
Right.
This whole idea of capturing changes as events
Yeah.
and triggering actions based on those events.
Yeah.
It seems like a pretty universal concept.
You're absolutely right. The transactional outbox pattern and the use of event streams, they're becoming increasingly popular in modern software development.
Okay.
They're not tied to any specific database or technology.
Right.
It's more of a paradigm shift, a way of thinking about data
Okay.
and how it flows through a system.
So it's not just about learning a particular set of tools,
Right.
but rather it's about understanding a fundamental concept
Yeah.
that can be applied in various contexts.
Exactly. Like learning the principles of physics. Once you understand them, you can apply them to, design and build all sorts of things.
That's a powerful way to look at it. So we've talked about the mechanics of using DynamoDB streams and Lambda functions to implement this pattern. But what about the broader implications?
Yeah.
What's the big takeaway for someone listening to this deep dive?
I think the key takeaway is that embracing an event-driven architecture
Okay.
can significantly simplify the way you build and manage complex distributed systems by capturing changes as events and using those events to trigger actions.
Yeah.
You can create a system that is, more responsive, scalable, and resilient. And remember, idempotency is key.
Okay.
Make sure you're thinking about how to handle those duplicate events gracefully.
So it's about thinking in terms of events.
Yes.
Understanding how data flows through the system,
Uh-huh.
and designing for resilience from the ground up.
Precisely. And it's an approach that can be applied across a wide range of domains and industries.
This has been incredibly insightful.
Yeah.
Before we started this deep dive, I was a bit intimidated by the whole concept of atomic operations and distributed systems.
Right.
But now I feel like I have a much better grasp of the fundamentals and how they can be applied in the real world.
I'm glad to hear that. And remember, even though we've covered a lot of ground, there's always more to learn.
Well, on that note, before we wrap up this part of our deep dive, I want to bring up another point that the article mentioned.
Okay.
It talked about potential security considerations when using DynamoDB Streams and Lambda functions.
Oh, yes. Security, a crucial aspect of any system.
Exactly.
Especially when you're dealing with sensitive data.
So what are some of the key things to keep in mind when it comes to securing this type of setup?
Well, first and foremost, you need to make sure that access to both DynamoDB and Lambda functions is properly restricted.
Oh.
You don't want just anyone, snooping around in your data or messing with your functions.
It's like having a strong lock on the door to your house.
Right.
You want control who has access.
Exactly.
And what they can do once they're inside.
And just like with a house, you need multiple layers of security. In addition to access control, you also need to think about encrypting sensitive data.
Okay. Both in transit and at rest.
So even if someone manages to bypass that first line of defense, they can't actually read the data without the encryption key.
Exactly. It's like having a secret code
Right.
that only authorized individuals know.
Right.
And then there are other security best practices to consider.
Okay.
Like using strong passwords, rotating credentials regularly, and implementing monitoring and logging to detect any suspicious activity.
So it's about taking a holistic approach to security, considering all the potential vulnerabilities, and implementing multiple layers of protection, kind of like a security onion, peeling back the layers to reveal even more security measures.
A creative analogy. And remember, security is not a one-time effort.
Right.
It's an ongoing process that requires constant vigilance and adaptation.
Makes sense.
As new threats emerge, you need to stay ahead of the curve and update your security measures accordingly.
So it's about staying informed, being proactive.
And always assuming that someone out there is trying to find a way in.
Exactly. The world of cybersecurity is a constant cat and mouse game.
Right.
But by understanding the risks and taking the appropriate precautions, you can significantly reduce the likelihood of a security breach.
Well, that's reassuring. And it just goes to show that building a truly robust and reliable system involves considering many different factors.
Yes.
Not just the technical aspects.
Absolutely. It's about understanding the bigger picture.
Right.
And taking a holistic approach to system design.
Well, this has been an incredibly insightful deep dive. We've covered a lot of ground, from the mechanics of using DynamoDB streams and Lambda functions to the broader implications of event-driven architectures and the importance of security. But I feel like there's still one piece of the puzzle missing.
What's that?
We've talked about how this approach can be used in an e-commerce context.
Right.
But I'm curious to explore other potential use cases.
Yeah.
What are some other real-world scenarios where this type of event-driven system could be beneficial?
Ah, yes, the real-world applications, where the rubber meets the road, so to speak. Let's see, where could we apply this powerful concept beyond the realm of online shopping carts?
I'm all ears.
Oh, how about this? Imagine like a financial institution that needs to process transactions in real time and also trigger fraud detection mechanisms. That's a perfect scenario for an event-driven architecture.
Oh, that's interesting. So each transaction would generate an event.
Right.
And that event could trigger a series of actions, like updating account balances and running fraud checks.
Exactly.
All at the same time.
And because we're using that transactional outbox pattern, we can be confident that both of those actions happen together.
Right.
No more worrying about, one action succeeding while the other one fails.
So no money mysteriously vanishing into thin air.
Right.
That's a relief.
And, this pattern, it's not just limited to financial systems. Think about IoT devices.
Right. You mean like my smart refrigerator that tells me when I'm out of milk?
Exactly. Imagine a network of sensors that are monitoring a factory floor. Each sensor reading could generate an event. And that event could trigger various actions like adjusting machine settings, sending alerts, or logging data for analysis.
So we're talking about building systems that can react to changes in the real world in real time.
Yeah.
That's pretty powerful stuff.
It is. And because these systems are event-driven, They're inherently very scalable.
Okay.
You can easily add more devices or sensors without having to, redesign the entire system.
It's like building with Lego blocks.
Right.
You can just snap on more pieces as needed.
A great analogy. And that kind of flexibility is really crucial in today's rapidly changing technological landscape.
This has been an eye-opening deep dive.
Yeah.
We've gone from this seemingly simple problem
Uh-huh.
of making sure that multiple actions happen together
Yeah.
to this powerful architectural pattern that can be applied across a wide range of industries and applications.
It's amazing how, a simple concept like capturing changes as events can lead to such profound implications for how we design and build software systems.
And it all comes back to understanding those fundamental principles, right?
Absolutely. Once you grasp those core concepts, you can apply them to all sorts of different challenges and come up with some really innovative solutions.
So to wrap things up, what's the one key takeaway you want our listeners to walk away with today?
If there's one thing to remember from this deep dive, it's this. Embrace the power of events. Think about how you can capture changes in your system as events and use those events to trigger actions. It's a powerful paradigm shift that can lead to more robust, scalable, and responsive systems.
Well said. And remember, always be prepared to handle those pesky duplicates.
Right.
Idempotency is your friend.
Couldn't have put it better myself.
This has been another fascinating deep dive into the world of distributed systems. Until next time, keep exploring, keep learning, and keep diving deep.
Happy coding.